Chapter 4 in Programming Logic and Design is our most complex chapter yet. Plan for more time to watch and understand this PowerPoint, plan for more time to read the chapter, and plan for more time to do your MindTap coding exercises. And as always, you know how to get in touch with me. So chapter 4 is about adding decisions to our code. Decisions is where we look at the value of a variable or a piece of data and we compare it to something, and then it will be true or false. And based on if it's true or false, we will do one thing or another thing. So we're going to look at the selection structure, better known as the if structure. We're going to look at the relational operators we use to compare the variable to a value or two variables to each other. We're going to look at making complex decisions with the AND logic, the OR logic, and the NOT logic. And then we're going to look at making a series of selection statements to define ranges of variables. And finally, we're going to look at a special case of the selection statement called the case structure. So Boolean expressions. Selection statements, if statements, are all geared off of Boolean expressions. A Boolean expression is you're asking a question that's either going to be true or false. If it's true, we're going to do one thing. If it's false, we'll do something else. So that could also, you could also think of it as yes or no or 0 and 1. So every selection structure is going to have a true, do something, and a false, do something. And then since we're doing structured code, we have one entry point, one exit point. Now it can also be the case that if the Boolean expression is true, we're going to do something, and if it's false, we're going to do nothing. So that's a single alternative selection structure versus a dual alternative where you do something if it's true and you do something different if it's false. So here is some logic using selection structures. Now this is not as complex as it looks because we're defining our variables. We're doing our housekeeping, which is just setting up our messages. We're outputting our starting messages and we're inputting the name. And then we're going into a loop where we look to see if the name is not equal to quit. While the name is not equal to quit, we're going to do the detail loop for that name. Well, the detail loop has a decision statement. Are the hours greater than the work week? If they are, we're going to pay regular pay and overtime. If they're not, if it's false, you're just going to get your straight hours times pay rate. Okay? And then we're going to output it, input the next name, go back up and keep doing the loop until they type quit. So if we look at the pseudocode for the detail loop, input hours. If hours is greater than work week, then we're going to do regular pay, which is rate times work week, 40 hours. And then the overtime is going to be hours minus work week, which in this case is 40 hours. So any hours above 40, you're going to get your rate times 1.5. You're going to get time and a half. Okay. Else, you just get however many hours you worked at the pay rate of $15 an hour. Then we output it. We input the next name. And then the loop will keep running, keep calling detail loop while name is not equal to quit, detail loop. So this is the pseudocode. If this condition is true, then do this, else do that. That is the basic form of a decision statement, an if statement. And we'll see the specific code format for C++ in a later slide. Next slide. So as I said, if the if condition, if the Boolean expression between the if and the then is true, this is what we're going to do. The else clause is only run if the Boolean expression is false. Pretty straightforward. So here's a pseudocode example. If hours is greater than work week, pay is going to be 40 times $15. That's your regular pay. Your overtime is only on the hours above 40, so we say hours minus work week times 15 times 1.5. So this is your overtime pay. And this is pretty standard calculation we'd have to do to get base pay, overtime pay. Now, else, we just do base pay, hours times rate, however many hours you work that week times your pay rate. Now, this is how we do this in C++. In C++, you say if, open parenthesis, you do your Boolean condition, which is comparing the variable hours to see if it is greater than the constant work week, close parenthesis. Everything that happens when it's true is between this open curly brace and this close curly brace. So here's the line of code. We're going to do all this calculation and we're going to put the value of that calculation into pay. Okay, close brace. Else, open brace, everything between these two curly braces is the else condition, the false condition. So pay is just hours times rate. So this is how we would do it in C++ versus pseudocode is right here. So you notice in C++ we don't use the word then. And in pseudocoding, we don't have these parentheses. You must have an open and close parenthesis around the condition, the Boolean expression, because this is going to evaluate to be true or false. If they work 40.5 hours, this will be true, and it's going to do this line of code. If they work 35 hours, it's just going to be 35 times 15, and that's going to be their pay. That's going to be the false condition. But this is how we do it in C++. So the relational operators is how we can do that comparison to see if it's true or false. And we can say equal, are the two things equal to each other, greater than, less than, greater than or equal to, less than or equal to, and not equal to. That is the 6 relational operators. So the two values on either side of that operator are going to be evaluated to see if the condition is true or false. Now be careful, because you can end up doing what we call trivial expressions. Is 20 equal to 20? That will always be true. Is 30 equal to 40? That will always be false. So you don't even need an if statement if you're doing something like that, because you know it's always true or you know it's always false. What we're going to be doing is using a variable and comparing the variable, the value of that variable, to another either constant or another variable. So the equivalency operator is the equal sign in pseudocoding, but I just want you to know in C++ we use the double equal sign. In fact, I think in Java you use the triple equal sign. That may be Python. I may have the two flip-flopped. But we use the equal sign in C++ to say, put this value into that. It's the assignment operator. In C++, a double equal sign is for comparisons. So then we have the greater than operator, which says if the item on the left is greater than the item on the right. The less than operator is when the item on the left is less than the item on the right. So if they're equal, that's going to be false. The same for greater than. We're not checking for greater than and equal to, we're just checking for greater than. The greater than or equal to operator, of course, will check to see if the item on the left is greater than or equal to the item on the right. And so on and so on. So less than or equal to and not equal to. And by the way, in C++, not equal is exclamation point equal, not equal. Because in math, for math, the exclamation point symbol means not. So not equals literally what that means in C++. So I thought I would just point that out to you. So this slide is basically talking about the not equal to operator can make your code seem more complex to a human being, because it's easier to say, is this equal to that, than to twist your mind around and say, is that not equal to that? It just makes your brain kind of think backwards. So when you write your statements, you want to, if you only need to do one thing, you want to write the statement so it's true to do that thing. Not when it's false, do what I want to do. So if you're using the not operator, the not equal to, that can just make your code more complex. So try to switch it around and think more clearly. Write it more clearly. We can write our conditions, our relational operators, a variety of ways. I could say if customer age greater than or equal to 65, they're going to get a 10% discount, else they're going to get a 0% discount. Now, I can accomplish the same thing by saying if customer age is less than 65, discount 0, else 10% discount. Now, I would write it this way. This is the direct way. We're doing something when it's true, else no discount. So in my opinion, the left side code is easier to understand. So if I had a choice of writing my code this way, greater than or equal to 65, or this way, less than 65, and actually doing my work in the else statement, I would not want to do it this way. I'd want to do it the way it is on the left. But you can do it. It's 6 of one, half dozen of the other. You just have to be careful, and you want to write your code as straightforward as possible because it's easier to debug and understand if you do that. So once again, let's look at this case. If customer code is not equal to 1, then 25% discount, else 50% discount. So this is kind of backwards because we're using the not equal. It's more clear if I say if customer code equals 1, they get a 50% discount, else they get a 25% discount. So this one on the bottom is more clear. You want to avoid that negative comparison if it's at all possible. And it should be possible to avoid it. Remember, good programming is about developing good programming habits, doing things in a way that is more straightforward and easier to understand, not only for the other programmers that might have to come behind you to work on that code, but for you, because 6 months later, you're not going to necessarily remember why you wrote the code the way you did. So you want to get in the habit of writing clear code so that it's easy to understand and debug. So common errors are to use the greater than operator, relational operator, when you meant to use the less than, okay? So, if a big value is greater than a small value, or, did you want it the other way around? So you got to take a step back when you're writing your if condition and make sure you've got the right operator. Another thing to look for is missing the boundary or limit. So if I go back a couple slides on that, right here, if I said if customer age greater than 65 instead of greater than or equal to, I would be excluding people that are exactly 65 from the discount. That would be a bug. That would be a boundary condition. It needs to be greater than or equal to instead of greater than. So you've got to watch that. Or if I did this, if I said less than or equal to over here, then people who are 65 years old would not get the discount. So that is what they're talking about on a boundary or limit required for a selection, is watching those little details. And when you do your test data, like if I was testing this program right here, I would make sure I typed in 65 for the customer age and make sure it was working correctly. I would type in 3 test values. I would type in a value less than 65, and that should trigger a discount of 0 as expected. I would type in 65, and in this code it would give a 10% discount, and then I would type in a number larger than 65. So in my testing, I would make sure that I have data that is on the border, below the border, and over the border. And that's just to avoid putting a bug in my code for a boundary condition. Now we can create a more complex condition check by doing a compound condition. Now I could say something like, if age is greater than or equal to 65, and discount ticket is true. If both of those are true, that's a compound condition. I'm checking for two things. And as we'll see later, I might have something like, if age is greater than or equal to 65 or discount ticket is true. So you could get the discount two ways. If you bought the discount ticket club membership, that gets you the discount. Or if you're 65 years or older, that gets you the discount. Right now we're talking about and. If you have a compound condition that's an and, you're going to have a first condition that has to be true, and then you're going to have a second condition that has to be true. So if the first one is true, we will go on to check the second condition. And if the second condition is true, then we're going to do something. Now you can see that in the flowchart on the next screen. So in this example of the pseudocode, we can see a compound condition. Over here in the pseudocode, let's look at the detail loop. If calls made is greater than calls, so calls is a constant of 100. So if the number of calls made is greater than 100, then the true part of the first if statement goes into a second if statement, so it's nested. If call minutes is greater than minutes, and minutes is a constant of 500, so if call minutes is greater than 500, so if the number of calls they made is greater than 100 and the call minutes is greater than 500, then the customer bill is going to get a premium added to it of $20. And only if those two conditions are true. And we'll actually see how to do this using an and keyword later. But this is a compound condition because we're using and logic. If this is false, it's just going to jump down to the end if. There is no else in this case. If this is false, it's going to go end if, and then it's going to output the answer. So only if both of these are true, only if calls made is greater than calls, yes, and call minutes is greater than 500, yes, are we going to charge the premium. Otherwise, we're going to exit this decision statement, and then it's going to exit the first decision statement. So that is a compound and logic. To be more efficient, since we're making two decisions, if one of the two decisions is more likely to be false, do that one first. So the reason we do that is if the first one is false, it will not do the second one, and you're saving CPU time. You're making your program run faster, because in a compound condition of an and, you only check the second condition if the first one is true. So it speeds up your processing time. So we could do it this way. If calls made is greater than calls, then we check the minutes. Or we could check for minutes first and then check for calls. It just depends on which one of these is more likely. And that's where you got to do some data analysis. You have to understand the data you're working with, because your data is going to inform you the best way to write this code. Do I want to write it where I check for calls first, or do I want to write it where I check for minutes first? And that could make a measurable difference in the performance of your program. One can run faster than the other. So we can actually now see this in C++. If, open parenthesis, calls made is greater than calls, if this is true, it's going to do all the code inside of these curly braces, open curly brace. And what do we have inside the true part of the first if statement? We have a second if statement. If call minutes is greater than minutes, then we have the curly braces for this true condition. So then we're going to say customer bill is equal to the customer bill plus the premium. We're going to add $20 to their bill. This is the end of the inside, the inner if statement. This is the end of the outer if statement. Now C++ does not strictly require you to put a semicolon on the end of the close brace, because the close brace basically stands for a semicolon as well, but I just have the habit of every line of code, everything I do, I like to put a semicolon on it. It's just a good habit. All right, so jumping in, going further. Now we could just use the AND operator and ask 2 or more questions in a single comparison statement. So each Boolean expression must be true for the entire statement to be true if we're doing an AND. Now in C++, we use a double ampersand to stand for the word AND. Okay, we don't say the word AND like we do in many other programming languages. So when you're doing an AND statement, you're going to have a Boolean expression on the left. If that is true, it's going to check the Boolean expression on the right. And if both of those are true, then the entire statement is true. In other words, I could say this: Mike Kent is a professor at San Jacinto College, and Mike Kent is President of the United States. Well, that's a false statement. The first part is true. I am a professor at San Jacinto College. The second part is not true. I am not the President of the United States. And for an AND to be true, both sides of the AND have to be true. Now, very often what will happen in a programming language is, since both sides of an AND have to be true, if the first condition on the left is false, it does not look at the second condition. It doesn't waste the CPU time, the CPU cycles, to look at the second condition, because it already knows the statement is false. If I said Mike Kent is President of the United States, that's false. And Mike Kent is a professor at San Jacinto College, that's true, but it doesn't matter that the entire statement has already been proved false because the first condition was false. So when you're bumping multiple conditions together with an AND statement, they both have to be true. So if the first one is false, it doesn't check the second one at all. So I'll show you this in C++ in just a minute. So using the AND operator will let us take several Boolean expressions. If A is greater than B, that's a Boolean expression. It's going to be true or false. And then we string it together with an AND. So in the example the publisher uses, the author uses, if I want to go to the movie and I have enough money, then I'll go to the movie. Now, if I don't want to go to the movie, I'm not going to bother to check and see if I have enough money. It doesn't matter, because if this is false, if this condition is false, it's not even worth checking the second condition. Now, if this one is true and I have enough money, if I have enough money is false, I ain't going to the movies because I can't get in the door. I can't pay for my ticket. So then the entire statement would be false. I can't go to the movie unless I want to go and I have the money. Both of those conditions must be true. Now, if we look at this in C++, I'm going to go back to the calls made. If, open parenthesis, calls made is greater than calls. So this first condition is going to be true or false. And, that's the double ampersand, call minutes is greater than minutes. If this is true and this is true, then they're going to pay extra money. Now remember, in C++, you've got to have a set of parentheses around the entire condition. So if, open parenthesis, you do your whole condition including the and then you do the close parenthesis. If both of these are true, and, remember, that's an and, then it's going to add the premium to the customer bill. Now, it's not required, but to make your code more understandable, you can use extra parentheses. So I could say if, open parenthesis, and then you see at the end the close parenthesis. I have to have that. But I have added in red here an extra set of parentheses around calls made greater than calls, close parenthesis, because this is going to be done first. This is going to evaluate to true or false. Then it's going to do this one and evaluate it to see if it's true and false. And if it's true and true, it will pay the premium. In fact, what it'll do is, if this is true, it will go on to check the second condition. If this is false, it will short circuit because it knows it doesn't have to check the second condition because the entire statement has already been proven false because we're using an AND. So if this is false, it's just going to skip down out of the if statement and continue on with the code. So this is the way I would write it personally. If I was writing it in C++, I would probably go ahead and use the extra parentheses just to make things more clear than up here. Although both of them are pretty clear. The average programmer they better understand an AND operator, the compound operator AND. So in flowcharting, this is my AND, calls made greater than calls, and calls minutes greater than minutes. This is making it 1. This is by doing it with 2 if statements like we did earlier in the PowerPoint. Let me go back to that. So this is doing it with 2 if statements. One, you have the outer if statement, and if this is true, it goes to the inner if statement, but it only goes to the inner if statement if the first one is true. So this is nested. We're still doing an AND. If you're doing an AND, I think this code is more clear to go ahead and use the AND operator because that's really what you're trying to do. And you can see right here, you can see the pseudocode for the nested if statement, one if statement inside of another versus using the AND operator. Now in pseudocode, we don't need the parentheses, but certainly you could add them. In C++, you've got to have if open parenthesis, blah, 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 close parenthesis. You do not say the word then, and then open curly brace, all the code that you want to happen when it's true. This is just one line of code, but we could have many, many, many lines of code, and then a closed curly brace. So that is the AND operator. So what are some of the common errors we make with the AND? So the second decision must be made entirely within the first decision. So what we're saying here is if the first condition is not true, only if the first condition is true do we go on to make the second decision. The AND operator is a binary operator. We have to have stuff on both sides of it. If I go back to here, you see we have one condition that evaluates to true or false on the left side of the AND, and we have a second relational operator, a Boolean operation. This is going to be true or false on the right-hand side. And if both are true, true and true, then we're going to add the premium to the bill. So that's what they're alluding to. Expressions should not be trivial. If the first part of your AND is false, always, it will never get to the second part of your expression. So trivial just means you're writing an if statement, but it's impossible for it to have a different outcome. It's always going to be true, or it's always going to be false. So this slide is getting into the, come on. Let me back up. The second decision must be made entirely within the first decision. So in this case, if calls made is greater than 100, we're adding the premium to the bill, and then we're checking to see if the minutes is greater than 500, and we're adding the premium to their bill again. So this is incorrect code because we're going to add the premium twice. If both conditions are true, they get the premium twice. If the first condition is true, they get the premium once, and if this is false and the second one is true, then they get the premium. So this is incorrect logic. This decision statement should be inside of this decision statement. They should be nested. They should be nested like this right here. If calls made is true, if calls made is greater than calls, if that's true, then we check for minutes. If that's true, then we add the premium. So this second decision statement is completely within the first one. This second decision statement is completely within the first one. Either way you look at it. All right, so now we can use the OR logic, okay? So the OR logic, let's go back to my statement earlier. Mike Kent is a professor at San Jacinto College, or Mike Kent is President of the United States. That entire statement would be true because one side of it is true. When you have an OR compound operator, then only one side has to be true. So if the first one is false, the entire statement could be true still because the second one could be true. So in other words, if I said Mike Kent is President of the United States, or Mike Kent is a professor at San Jacinto College, that's a true statement because the second half is true. It's only false, and OR is only false if both sides are false. Now in C++, we use the double vertical bar for the OR operator. We don't use the word OR, we use the double vertical bar. And this is typically the vertical bar above your enter key. It's usually shifted. It's on the shift. So, are you free for dinner Friday? Or are you free for dinner on Saturday? If either one of those is true, then we can go to dinner. Okay? So here is an OR condition. So in this case, if the calls made is greater than 100, we want to charge the premium. Or if the text sent are greater than the number of texts that's allowed, we're going to charge the premium. So if this one is true, we're going to add the premium. If this is false, we're going to check the second one. And if it's true, we're going to add the premium. And only if both are false will we skip the premium. And you can see the pseudocode right down here. If calls made is greater than calls, charge the premium. Else, check for the second one, charge the premium. So this is how you would write it if you're nesting it, if you're doing a nested if structure, decision structure. We'll also see using the OR keyword to do this in a little bit later. So I'll show you this actually in C++ right here. If calls made is greater than calls, or call minutes is greater than minutes, we're going to add the premium. So if this is true, or this is true, or if they're both true, we're going to charge the premium. Now, if they're both false, it will skip over it and come down to the next line of code. Now, once again, in C++, for readability, the extra parentheses are not needed, but it helps make your code more clear. It's clear that it's going to do this condition and evaluate it to see if it's true or false, or then it's going to check the second condition. So if either one of these are true, that makes the entire statement true, and we're going to add the premium to the bill. So to optimize my code, since I can ask either question first, on an OR statement, if the first question is true, there's no need to ask the second question. So you want to ask the question that is most likely to be true first. Now, once again, you have to understand your data to know which one you should ask first. And if they're both about 50-50, then it doesn't matter which question you ask first. But you can make your program run faster by asking the right question first on an OR. So you're eliminating as many extra decisions as possible if you set your decisions up in the correct order. So we could write it this way. We could check for calls made first, and then check for texts sent second, or we could check for texts sent first, and then check for calls made second, depending on our data. That's all they're saying right here. So remember, with the OR statement, only one of the two conditions has to be true for the entire statement to be true. So place the question first that's most likely going to be true. The computer is going to do one at a time, and that will make your code more efficient, especially if it's got to process millions and millions and millions or billions and billions and billions of pieces of data. You can make your program run considerably faster by working smarter, not harder. Now, in programming, when we use the word and, it has a very specific meaning. It means condition A has to be true and condition B has to be true. But when you read this in English, it very often means if the first condition is true or the second condition is true. So if you read this sentence in English, add $20 to the bill of anyone who makes more than 100 calls and to anyone who has used more than 500 minutes. In programming talk, I think they mean the word or. Okay, the word or. So this is something you need to clarify from your users when you're getting the requirements for a program so you don't write the code the wrong way. Because you as a programmer, the word and has one meaning, but to the general non-programming public, it probably has a different meaning. So watch out for that. So avoiding common errors in an or selection. Make sure your Boolean expression is complete. They are complete. Make sure that the selections are structured. Okay? Make sure to use the or selection when they're required and make sure they're not trivial. So let me show you what they mean by are they complete. And this is a common error I see novice programmers make. So they're trying to say, what I'm trying to say right here is if hours is greater than 20 or hours is less than 40. You can't do it that way. You've got to say if hours is greater than 20 or hours is less than 40. Now, this is an example of a trivial expression. Why is it trivial? Well, that won't compile. This will compile, but will always be true. Okay? Because if hours is greater than 20, this is true. Okay? No matter what value you come up with, one of these two will be true. If hours is 0, hours less than 40 will be true. If hours is 21, this will be true. And this will be true. What if hours is 60? Well, this will be true, but hours less than 40 will be false. So this is a trivial expression because no matter what value I have for hours, one side or the other will be true. So that's a trivial expression. That's what you have to watch out for. I think what they really meant to do here was if hours is greater than 20 and hours is less than 40. So let's see, let me pause here and edit that. So if we look at right here, like I said, this is a trivial expression. This is a trivial expression. No matter what value I think of for hours, it will always be true. 0, hours is not greater than 20, so this is false. But 0 is less than 40, so the entire statement is true because it's an or. 21, that's true. The entire statement is true, even though hours less than 40, and that's true. So we're true on both sides. 41, this is false, but greater than 20 is true. So what they probably meant to do here is use an AND operator. If hours is greater than 20 and hours less than 40. So they're at least half time, but they haven't worked 40 hours. So on the like I said, on the previous slide here, when I was trying to show you a non-complete statement, I ended up, even when it is complete, it's trivial because this statement is always true. So probably the programmer that would have been writing this was using or when they meant to use and. So just watch out for that and you can do the same thing with and. You can make it so that it will always be false or it will always be true. So you need to test your logic by thinking in your mind, if ours has this value, what happens? If ours has the next value, what happens? If ours has the next value, what happens? So in this case, since I'm checking against 20, I want to pick a value less than 20 to see what happens. I want to pick a value of 20 to see what happens, to check my border conditions. I want to pick something between 20 and 40. Then finally, I want to pick 40. And last of all, pick something greater than 40. So those are the values I would want to test to see if my logic is correct. So if we want to check for a series of range values, we're going to write a series of if statements starting either from the lowest value and working to the highest, or working from the highest to the lowest. And you typically want to use greater than or equal to or less than equal to, not less than or greater than. So if we're trying to say the discount rate is if you buy 10 or fewer items, the discount rate is nothing. 11 to 24 is the next range. That's a 10% discount. 20 to 50 is 15%. 51 or more is a 20% discount. We're trying to write a series of decision statements nested together to handle this situation. So let's look at the nested if statements here. Well, let's look at it in the flowchart first. So the first thing we do is we say, is the items ordered less than or equal to range 1? So range 1 is 10. So if this is true, if they bought less than 10 items, they're going to get discount number 1, which is 0. Okay. Else, we're going to check for the second range. The second range is 24. So is the number of items ordered less than or equal to range number 2? If that's true, they're going to get the 10% discount, which is discount 2. Now, we don't have to check to see if it's greater than 10, because we already ruled that out with the first if statement. This one we know that it's not less than 10 because we wouldn't have got to the second if statement otherwise. So if that answer is no, we go to the third one. And the third one is going to check for range 3, and range 3 is 50. So if it is greater than 50, they're going to get the best discount. If it's not, they're going to get the 15% discount. So if items ordered is less than or equal to 10, no discount. Else, if items ordered is less than or equal to 24, they're going to get the 10% discount. Else, we're going to check for the third one. If items ordered is less than 50, they're going to get a 15% discount. Otherwise, they have more than 50 items, so they get the 20% discount. So this is a nested if, and we're working from smallest to largest to optimize the code. So avoiding common error still, avoid dead or unreachable paths. Don't check for things that can never occur. And that means you have to understand your data. So if the number of hours in a week is in a data file that they worked, it's going to be between 0 and 168 if it's valid data. You don't have to check for 169 or 200. You know, the program that put the data in the file did that validation for you, so you don't have to do it again. Never ask a question if there is only one possible outcome. If you know what the results will be, you don't have to test for it. And don't test for the same range limit multiple times. So in this example, if we're checking for items ordered is less than or equal to range 3, less than or equal to 50, then they're going to get the 15% discount. We don't have to have a fourth check to make sure it was greater than range 3, because the only way it was no on the third question is if it was greater than 50. So this is just extra work we don't have to check on. So that's a dead path that is making the program do more work than it needs to do. In the same point, we don't need to do an and here. See, the first check is items ordered less than or equal to 10, range number 1? If so, they don't get a discount. The second case, we're saying if items ordered is greater than 10 and items ordered is less than or equal to 24, well, we already know it's greater than 10 because it went to the no path of the previous question. So we don't need to do this first part of the check. We're doing extra work. We're testing the same range multiple times. And because we're checking from smallest to largest, it allows us to do that efficiency. Same thing here on the third check. If items ordered is greater than range 2, well, guess what? It would not have taken the no path unless it was greater than range 2. So we're doing extra work here we did not need to do. All right, so get even more complex. Now we're going to do 3 conditions. If score 1 is greater than the minimum score, greater than or equal to the minimum score, and score 2 is greater than or equal to the minimum score, and score 3 is greater than or equal to the minimum score, then they passed. Okay, otherwise they failed. When we use an and, that means all 3 of these must be true. That's what the and does. Whatever's on both sides of the and has to be true. So if only one of the scores has to be greater than the minimum score to pass the class, then it's going to check for all 3 of these. And if any one of these is true, then the entire statement will be true. So when only one of the multiple conditions must be true, use multiple ORs. Now it gets more complex. When we start mixing and or, it does the and operators first and then does the ors. So in this case right here, if age is less than or equal to 12 or age is greater than or equal to 65 and rating equals G. So it's going to do age greater than or equal to 65 and rating equals G first. It's going to evaluate if that's true or false, and then it's going to do the OR. So what you should do is, if you want the OR to be done first, use parentheses. So by putting these parentheses right here, it's going to check the age to see if the age is less than 12, less than or equal to 12, or the age is greater than or equal to 65. It's going to evaluate that to true or false, then it's going to do the AND. So what I like to do is always use parentheses in these situations to make sure it's evaluating it the correct way. Because if you don't remember that ANDs are done first and you just evaluated this in your mind left to right, you would get it wrong because the AND is done before the OR. If you use parentheses, it will always be documented, it will always be clear. So mixing ands and ors, of course, makes your logic more complicated. So you can avoid mixing ands and ors by doing nested if statements, or like I did, use parentheses to make it clear. So here's what they did. So instead of having to use ands and ors, they broke it into multiple nested if statements to see if the discount applies. Case structure. The case structure is a more specialized decision statement that can check only for specific values. So if there's like customer codes or discount codes that are certain discrete numbers, it can't be a range. If it's just certain simple numbers, a case statement will make your code simpler. So in this case, it can be year 1, year 2, or year 3. It's not a range of years. So in this case, if you're in your first year, the tuition's $175. If you're in your second year, we give you some discount, it's $150. If you're in your third year, it's $100, and if you've made it to your fourth year, it's $60. Don't you wish it worked that way? So in the case statement, we're looking at the value of year. here's a nested if statement to check for those values. A case statement's like this. Case year. If it's 1 colon, the tuition's 175. If it's 2, it's 150. If it's 3, it's 100. And the default is 60. So this is simpler and easier to understand than a nested if statement. So that's a situation where we would want to use the case statement, but it's only for specific values. Like in C++, you can't say case 1 to 5, case 6 to 27. Can't do that. You're going to have to use a nested if statement for that. And that brings us to the summary. So we looked at decision statements, we looked at the relational operators, we looked at and how that works, we looked at or and how that works, and we looked at combining ands and ors. We looked at common errors such as trivial expressions that are always true, or doing something that we didn't mean to do and that you have to test. You also want to make sure that you avoid the not operator anytime you can, because it makes things more complex. And just remember that the and operator is done first. It takes precedence over the or operator, but better yet, use your parentheses. And then we took a quick look at the case structure. And that is the lecture for Chapter 4. If you have any questions, you know how to get in touch with me.